Oh yeah, it's gonna be another one of those videos.
I know that's controversial, but this is my YouTube channel. I get to say my opinion around in these parts, okay? The internet has endless footage of the AI doomers talking about how generative AI has peaked. There's no more data to train the new models. The AI bubble is popping. While this might seem logical based on media coverage, it's not exactly true. Let's talk about Google DeepMind and what they're doing with synthetic data. Okay, so as it turns out, there is actually a really big problem with large language models. You take a whole bunch of input data, or a prompt, if you will, and you put it through a whole bunch of steps, different functions, and the model spits out an output. Or, an answer to your prompt. This answer is just really the most likely solution out of an infinite number of answers or solutions. And to be honest, it's actually pretty good most of the time. So what's the problem? Once you train a neural network, they can't learn new information like a human being can. It's like teaching a baby how to walk, and then they can't learn anything after that. So that's why all these generative AI companies want to train their models on basically the entire internet, and that's why they keep putting out model after model. As soon as a new model comes out, let's just use OpenAI as an example, as soon as they put out ChatGPT 4, they were already training 4.0. And just like they released 4.0, they are almost definitely training the next model right now. So are we running out of data then? I mean, kind of, but only because these models need to train on all the data. They're limited to learning only what humans have already produced so far. That's just an artifact of how neural networks work, unfortunately. So of course, these generative AI models aren't just a neural network. There are lots of things. That is to say, there are lots of different components of what goes into a generative AI model. They have a transformer-based natural language processing neural network, and they can do other functionalities. Like they might have a convolutional neural network that can recognize and produce images. They might have a reinforcement learning algorithm. I'm going to do a whole separate video about reinforcement learning. So we're going to set that aside for now. And if you want to learn about it, subscribe to the channel. We'll talk about it in a few weeks. What you need to know right now for this video is that these things train on a massive amount of data. So the more we build, the more it seems like we're putting more data into this. And all it does is produce a marginally better result, but a not as good as expected result. We would expect the chart to look like this, but it looks like this. That's the problem that people are talking about, why they say that we're running out of data and that AI has peaked. But if you're on the Google DeepMind team, you looked at this and said, nah, fuck that. I can do much better. Okay, so if you followed me for a while, you have seen this video before. Probably. It's my most viewed video. Google DeepMind is the creator of the spookiest algorithms. And by that I mean, imagine Stephen King and Quentin Tarantino got together for a beer. At least in my opinion. And I know that's controversial, but this is my YouTube channel. I get to say my opinion around in these parts, okay? The video that I showed you that you probably have watched was about Google's algorithm Alpha Geometry. They have come out with Alpha Geometry 2 and most recently Alpha Proof. Those two algorithms, Alpha Geometry 2 and Alpha Proof, they got together one night. One thing led to another, and this happened. Alpha Geometry 2 is basically an improved version of the Alpha Geometry algorithm that originally scared the shit out of me and kept me up at night. Again, that's not necessarily bad. That shows that we're making progress in AI. I'll put a link to the paper for alpha geometry in the description. It is an open access article. There is no article about alpha proof yet, but on the Google DeepMind page, they have released a press release about it. It is a reinforcement model for math reasoning. Both alpha geometry 2 and alpha proof rely on synthetic data. That's kind of Google DeepMind's jam. So what the fuck is synthetic data? In short, synthetic data is any data that is created by artificial intelligence. I've heard people say that it's nonsense data or that it's randomly generated. Neither one of those two things is true. It's just data that is derived, if you will, from data that already exists, that was fed to the algorithm. Human-produced data or synthetic data. You can get synthetic of synthetic and on down the line. Let me show you how to make synthetic data. Basically, we have three choices here. You can create synthetic data by identifying a distribution. For example, normal distribution. You could have this thing here. Where x is equivalent to the normal distribution of the mean of the distribution, which is what we're putting as mu. And sigma squared is the variance of the distribution. Or you could use a mathematical model. For example, we'll use linear regression. So linear regression is just a line, all right? So you can have y equals ax plus b plus the error term. So y is your dependent variable, just like in, 8th grade algebra class or whenever you took algebra. And x is your independent variable. A and b are coefficients, and then e is either an error term or just noise.
Now, a lot of times when we create models, we actually have more than one variable that we need to consider. We have multivariable or multivariate statistics for that reason. Here's an example of how we can use that to generate synthetic data on the board.
So let's just use a multivariate Gaussian distribution. Gaussian meaning normal, like what we used before. So you could have x being equivalent to this thing, where x in this case is a vector of generated synthetic data. And U is the mean vector. Capital sigma is the covariance matrix. If you need a little bit of review on vector calculus, linear algebra, or statistics, I do have some review sheets available for pretty cheap on my website. These funds go toward helping my students. So in my previous video about alpha geometry, I don't think I did a very good job of explaining why the algorithm kept me up at night. Here's the thing. I looked at what it produced for synthetic data, and it had a remarkable ability to reason through problems that we haven't seen from a previous algorithm before. To be honest, it did better than some of my pre-calculus students did. The first thing I tell them when they're looking at a problem about a shape is draw the shape and label everything that you already know. That's exactly what the algorithm did. Okay, it did a lot of excess stuff that wasn't necessarily needed, but it wrote down everything that it knew about the shape. But here's the thing, humans and machines do think differently. Human students resist writing down. They look at the shape, they feel overwhelmed. The computer doesn't have that problem. Now, here's the difference. A human will sit there and look at a problem and decide how to solve it. A large language model will just dive in right away. And when we think about human researchers don't just Google shit, okay? We form hypotheses, we go collect new novel data, and then we analyze that data and test it against the hypotheses that we formed. And then we make conclusions. That is what these Google DeepMind algorithms have been able to do. And that is the part that scared the shit out of me. A lot of AI bros, myself included, think that synthetic data is really the key to creating human-like artificial intelligence, or just a crap load of AI agents seems to be the thing that we've all pivoted to. Because this is the way that we get a machine to emulate the way that human beings think and actually be able to use the scientific method. However, most of us agree that the non-numerical synthetic data is not great. Synthetic data does happen to work amazing for logic and puzzles, but not as well for more abstract things that come from humans, which humans are part of nature. So we'll just call it a byproduct of nature. Things that are nature second removed, I guess. Complicated data sets that don't fit onto a math equation.
Okay, so we've gone over the examples of what we would do if this is numerical data. What if it's not numerical data? What if it's an image or text or any number of more complicated data sets that you might find in a large language model? You know, like the whole theme of this entire video. Well, we need a more complicated model for that. In most cases, we would use what is called a GAN, which is a generative adversarial network. Okay, it's basically two neural networks that are fighting each other. Now, you may have noticed that I have a neural network on my shirt. These two neural networks, or adversaries, would look like this. Okay, so not quite exactly.
It's basically two neural networks, or one could say adversaries, or dueling neural networks, with a generator function, which we're going to call G, and a discriminator function, which we're going to call D, because we're super clever. We teach the discriminator to discriminate between real data and synthetic data, or fake data, okay? So we can have X real and X fake. We're going to find this thing called the Nash equilibrium of a minimax game. What the fuck is that? Well, it's this, okay? You'll notice that this equation does not have statistics shit. They're built into the dueling neural networks. All right, here's the thing. There is statistics in that, and statistics doesn't really represent nature all that well sometimes, especially if it's connected to human stuff. As an example, you'll notice that extremely rare things happen in the stock market a lot more frequently than they're statistically supposed to, because it's human stuff. Art, language, music, they don't follow a bell curve shape. This shape is a statistic shape. You can calculate the area under this curve and divide it into pieces. This shape is a biology shape. The shape is a fractal. It has an infinite area, so you can't calculate it. That means that you can't divide it into multiple pieces. In my opinion, without having done the significant amount of research required, I think that one of the main reasons why we have trouble creating synthetic data for human stuff, art, complicated data sets, language, is because we have trained it on a statistic shape when we should have trained it on a fractal. Anyway, the fact is, synthetic data works great for numerical stuff. Logic and reasoning skills like math, that is what alpha geometry and alpha proof are doing. Google shoved some reinforcement learning in there with an LLM, and they were able to get the machine to do what looked like thinking. So in 2015, Google DeepMind developed DeepQ networks. This algorithm was created to play Atari, and it was really good at Atari. DeepQ led to AlphaGo. It is an algorithm that learned how to play the Chinese game of Go. It beat Lee Sedol, who at the time was the world's best human Go player, 4 out of 5 games. They got it to do this after they gave it human Go games as an example and then let it learn how to play. And it played against itself after learning from the human data. All right. So in other words, it took human data and created synthetic data, lots of synthetic data. And then it was able to use that synthetic data to learn how to beat Lee Sedol 4 out of 5 times. This was revolutionary because Go is an extremely complex game. The algorithm can't just learn every combination or permutation of the game because that set is really big. We may as well just call it infinite. Infinite. We've talked about infinite sets already a few times. It was already able to demonstrate that it can learn how to deal with an infinitely big set of data. Anyway, they adapted AlphaGo a few times and applied it to chess and shogi, which is basically Japanese chess, and it was able to beat the top performing human players once again. And they actually got this version of the game to beat these players without even teaching it off of human games first. So it had no human data at all and produced synthetic data anyway. So that is a pretty big leap. You might be wondering how the f did it do that? We'll get into it, okay? In 2019, they came out with MuZero, which was able to learn how to play games without even learning the rules of the game. Those algorithms then gave way to something completely new, AlphaFold. It's a whole new thing, okay? It takes amino acids and figures out how to create a protein from folding them. Google DeepMind took an algorithm that could play games and basically beat every human that it went against, and created something that very well could create the cure for cancer in 1 year. And now we have all these math algorithms, and alpha geometry and alpha proof can prove math equations better than most people, okay? It got a silver medal, but it was almost gold in the Math Olympiad. Geometry is the key here because geometry is where we learn how to prove stuff, all right? That is when we are first introduced to pure mathematics of just prove the shit that's on the paper. And once you learn how to do that with geometry, you can do it with trig, you can do it with calculus, you can do it with topology. So remember how I said that the difference between how machines think and humans think is that humans will sit there and think about the problem. What's scary is that alpha proof will sit there and think about the problem, just like a human being. So in addition to learning math, it is learning how to human. I don't know, I kind of find that a little spooky. Don't you find that spooky? This could potentially blow up the world of generative AI. And by that, I mean blow all the other models out of the water, leave them in the fucking dust. Which is quite the coincidence because Google would like to put this into Gemini. In fact, they've communicated that they are going to put it into Gemini. That could create thinking machines like what we have not seen yet. It could accelerate human development and machine development by an exponential amount. There are some things that have to fall in place first before we can do that. So in other words, I'm about to dump some cold water onto this whole math algorithm thing. In a way, synthetic data cuts down on the cost it takes to produce these models because you don't have to license data. In another way, it also brings costs up because all of these steps are not necessary and each one takes computing power. It definitely helps mitigate the issue of access to data. And as we stated before, the issue with any neural network is that you can only train it once. When you add reinforcement learning, like what Google has been doing with their DeepMind algorithms, the model all of a sudden can learn a wider variety of things. But they still can't be trained on new data. So them's the breaks, game over. This is the reason why people say that AI has peaked. Research is currently leaning toward trying to figure out a way to create a model that can actually learn new information once it has been trained. That is kind of the next jump that we need to make in our development of AI models in order to get either human-like AI or AI agents. But that's not the only skill that we need in order to have a chance. There's actually a bunch more missing links, which I actually have already made a video about.